The quest for extraterrestrial life has propelled incalculable sci-fi stories and has even fueled missions by NASA. Quite possibly one of the most charming spots in this search is Europa, a moon of Jupiter, which many believe could hold crucial data. Bill Nye, the notable science guy, is among those who advocate for additional investigation of Europa, believing that this heavenly body may be vital to unraveling the mysteries of life beyond Earth. NASA's Explorer 1 shuttle, launched in 1977, made a remarkable discovery outside our solar system. This discovery has drawn the attention of some of the most brilliant minds today, including Bill Nye. What Explorer 1 found was ionized gas particles actively colliding and interacting just beyond the heliosphere, the bubble-like region created by the solar wind. These readings provided significant insights into what conditions may be like beyond our solar system. Could these be markers of extraterrestrial life? This question has captured the imagination of researchers and space enthusiasts alike. Bill Nye has long been a leading figure in the quest for extraterrestrial life. His passion for the unknown is evident in his interviews and talks, where he frequently stresses the importance of space exploration. The discovery made by Explorer 1 has further fueled this passion, offering new information that could possibly answer the age-old question, are we alone in the universe? To grasp why this discovery is so critical, it's essential to return to the beginning of space exploration and the events leading up to the launch of Explorer 1. In the mid-1970s, NASA had recently accomplished a great achievement by sending humans to the moon. This success ignited worldwide excitement within the academic community, and plans were soon in progress to explore much farther into space. NASA's next objective was to study the outer planets of the solar system. However, sending humans on such a mission was not yet practical. The immense distances and the limitations of 1970s technology made it necessary to rely on robotic spacecraft for these ambitious explorations. At the time, the Cold War was in full swing, and the U.S. was in a fierce rivalry with the Soviet Union. This competition extended into space, where both countries were striving to demonstrate their technological superiority. The Soviets had made the first significant strides in space exploration, launching the first artificial satellite in 1957 and sending the first human, Yuri Gagarin, into space in 1961. However, the U.S. caught up with the Apollo 11 mission in 1969, landing astronauts Neil Armstrong and Buzz Aldrin on the moon. This triumph was a turning point in the space race, but the U.S. realized it couldn't rest on its laurels. The competition with the Soviet Union continued to drive NASA's ambitions. To maintain their lead in space exploration, NASA aimed to go beyond the moon. The goal was now to explore the outer planets. The agency began designing spacecraft that could travel deep into space. One of NASA's first efforts was the Pioneer 10 spacecraft, launched in 1972. It became the first to fly by Jupiter and send back images. Pioneer 11 followed the next year, also heading toward the outer planets. However, NASA needed a more advanced spacecraft that could capture detailed images and data, not just from Jupiter but also from Saturn, Uranus, and Neptune. This led to the development of the Voyager program. The plan was ambitious, to utilize a rare planetary alignment known as the Grand Tour to slingshot the spacecraft from one planet to the next using gravitational forces. This alignment, occurring only once every 156 years, would allow NASA to study all the outer planets in a single mission, saving both time and money. To achieve this, NASA built two Voyager spacecraft. Voyager 1 was designed to take a shorter route, visiting Jupiter and Saturn, while Voyager 2 would follow a longer path to reach Uranus and Neptune. On August 20, 1977, Voyager 2 was launched, followed by Voyager 1 on September 5 of the same year. These twin spacecraft would go on to make some of the most astounding discoveries in the history of space exploration. Voyager 1 began capturing images of Jupiter on January 30, 1979. These photos revealed details of the gas giant that had never been seen before, including its Great Red Spot, a massive storm that has been raging for centuries. However, Voyager 1's mission didn't end there. After completing its flyby of Jupiter, the spacecraft continued on to Saturn, where it sent back even more valuable data. The discoveries made by Voyager 1, especially its detection of ionized gas particles beyond the solar system, have had a profound impact on our understanding of the universe. As the Voyager missions continue to send information from the farthest reaches of space, the quest for extraterrestrial life remains as urgent as ever. Bill Nye and other researchers believe that exploring places like Europa, with its subsurface ocean, could provide the next major breakthrough. What we learn from these missions could change our understanding of life in the universe forever. Every 96 seconds, Voyager 1 captured images and compiled them into a color stop-motion video. Using this technique, Voyager 1 was able to send back a film showing 10 rotations of the largest gas giant. By February 10, Voyager 1 had entered the planet's moon system, sending back film of regular satellites orbiting the gas giant. Before long, it discovered a thin ring of dust and ice surrounding the planet, invisible from a distance. This indicated that Saturn was not the only planet surrounded by rings. The ring was only under 30 meters in diameter, puzzling researchers about how little they knew about this planet. By May 5 of that year, Voyager 1 had its closest encounter with the giant planet, separated by a mere distance of 174,000 miles. During this extraordinary event, the spacecraft encountered several of Jupiter's moons, including Io, Europa, Ganymede, and Callisto. The photos it sent back provided incredible insights into the bizarre universe of natural satellites, as some of them had very little in common with our moon. These satellites are known as the Galilean moons, named after the astronomer Galileo Galilei, who discovered them in the 17th century through his telescope. One of the smaller moons seen by Voyager 1 was Amalthea, a reddish and irregularly shaped satellite with a strange surface composition. Images sent by the spacecraft showed that it was made up of ice and silicate materials. The surface became red due to the presence of organic material, and its unusually irregular surface indicates that it has undergone very little internal activity compared to the other satellites. Io was found to be the most geologically active body in the solar system, with many active volcanoes and lava flows visible from its surface. These volcanic activities were triggered by tidal heating caused by Jupiter's immense gravity, making the satellite look more like a volcanic hellscape than a moon. Europa was most notable for its smooth, icy surface covering a vast expanse of water underneath. Many researchers believe that life could flourish beneath the ice, making the satellite an excellent candidate for extraterrestrial life. And so on. The exploration of Saturn and beyond. After Voyager 1's successful encounter with Jupiter, a critical course correction was made to ensure the spacecraft didn't drift aimlessly across the solar system. This adjustment prepared it for its next major destination, Saturn. By October of that year, another course correction was performed to avoid a potential collision with Titan, Saturn's largest moon. By November 12, 1980, Voyager 1 made its closest approach to Saturn, passing within 8,000 miles of the planet's cloud tops. The spacecraft revealed astonishing new details about Saturn's complex ring system, discovering thousands of smaller ringlets within what was once thought to be a few large, distinct rings. It also identified peculiar transient structures within the rings, later named spokes, shadows cast by dust particles suspended above the ring plane. Additionally, Voyager 1 discovered 5 previously unknown moons orbiting Saturn and confirmed that small shepherd moons played a role in maintaining the sharp edges of the planet's rings. These discoveries helped explain why Saturn's rings remained well-defined over time instead of dispersing into space. However, one of the most intriguing aspects of Voyager 1's mission was its encounter with Titan. Unlike the other moons, Titan was shrouded in a thick orange-hued atmosphere that completely obscured its surface. Scientists were particularly excited because Titan's atmospheric composition, rich in nitrogen and hydrocarbons, seemed strikingly similar to what Earth's early atmosphere may have been like before life emerged. Voyager 1's instruments detected that Titan's atmosphere had a surface pressure similar to Earth's, though its frigid temperatures of -290 degrees Fahrenheit -179 degrees Celsius meant that any liquid present would likely be methane or ethane rather than water. This discovery suggested that Titan might be the only other place in the solar system where liquid could exist on the surface, fueling speculation about its potential to harbor some form of life. Since Voyager 1's trajectory took it on a path that would not allow further planetary encounters, NASA prioritized Titan's exploration over sending the spacecraft to Uranus and Neptune. Instead, the job of exploring those distant ice giants was given to Voyager 2, which continued its own journey toward the outer solar system. The grand finale and humanity's message to the stars. With its planetary encounters completed, Voyager 1 was placed on a trajectory that would take it beyond the solar system. But before leaving, NASA had one final mission in mind, capturing the family portrait of the solar system. On February 14, 1990, at a record-breaking distance of 3.7 billion miles from Earth, Voyager 1 turned its camera back toward home. Among the 60 images it captured was a now iconic photograph, the pale blue dot. This image, showing Earth as a tiny speck in the vastness of space, became a powerful symbol of our place in the universe. Astronomer Carl Sagan, who had advocated for the image, famously reflected,